The automatic digital network is part of the Defense Communications System and provides the single integrated computer-controlled network for Department of Defense record communications. The system is known by the acronym Autodin. Autodin provides traffic channels for messages relating to command and control, operational, intelligence, logistical, and administrative record traffic. As an introduction, we will examine the present configuration of the worldwide Autodin system, its capabilities, and operating characteristics. This Autodin Switching Center, or ASC, is the hub of the Autodin system. It contains the computers or central processing units, which are the nerve centers of Autodin. There are presently 19 automatic switching centers located strategically throughout the world. Nine of the switches are located in the continental United States and Hawaii. 5 of these are operated and maintained by the Air Force, 2 by the Army, and 2 by the Navy. They are leased by the Department of Defense from the Western Union Company. There are 10 switches located overseas. 4 are in Europe and 6 in the Pacific. They are owned, operated, and maintained by the Department of Defense. 5 by the Army, 4 by the Air Force, and 1 by the Navy. There is a physical difference in the design of the hardware systems used in the switches, depending on whether the switch is an overseas government-owned type or a CONUS leased type. However, they are functionally the same. System compatibility is maintained by similar software programs which provide identical services to the users. Autodin serves over 1,500 tributary terminals or subscribers throughout the world. Each subscriber terminal is connected to one or more of the Autodin switching centers. Subscribers consist primarily of DoD organizations, but Autodin also services other governmental agencies, including the Federal Aviation Agency, General Services Administration, Department of State, and the Foreign Broadcast Information Service. Non-governmental agencies are also supported, including the American Red Cross and military banking facilities. The Autodin switching centers are interconnected by more than 60 inter-switch circuits known as ISTs. Each switch is connected to 3 or more of the other ASCs, including at least 1 outside of the area. These interconnections have been designed to ensure continuance of the network in the event of the failure of a switch or a circuit between switches. The inter-switch circuits are both leased and government-owned. Signals travel over diverse transmission media, including satellite, tropospheric scatter, microwave, land cable, and submarine cable systems. Autodin switches provide store and forward service for record message traffic to subscribers who operate equipment at speeds from 60 words per minute to 6,400 words per minute. Message traffic is processed at all levels of security on a first-in, first-out basis according to precedence. The customers operate the terminal devices, which are defined by varying modes of operation, according to the operating speed and degree of complexity of the terminal equipment. Approximately 60% of the terminals are sophisticated multi-element terminals, and 30% are relatively simple teletypewriter terminals. The remaining 10% are a combination of the two. The Autodin system accepts messages inputted by paper tape, punched card, or magnetic tape. The Autodin Central Processing Unit, CPU, converts the input media to a common system. The output message can be delivered in any of the three media designated. Autodin is capable of accepting and delivering messages in either the Joint Army-Navy-Air Force publication, the JANAP 128 format, or the Allied Communications publication, ACP 127 format. On the average day, the customers served by Autodin introduce approximately 200,000 messages into the system, which result in 400,000 messages being delivered to addressees. The increase results from many messages being sent to more than one addressee. Flash messages are received and delivered terminal to terminal in 3 minutes or less, while the average for messages of all precedence is less than 15 minutes. Customer-originated traffic is divided into 60% teletypewriter and 40% data traffic, while the delivered traffic is 75% teletypewriter and 25% data traffic. The difference in percentage is a result of the multiple address teletype messages. The throughput capacity of an Autodin switching center is the rate at which message traffic can be processed in and out of the switch. The limiting factor for throughput is the capacity of the input and output devices which function with the CPU. In the present configuration, the capacity of the CPU far exceeds the capacity of the input and output devices which function with the CPU. The performance of Autodin is best demonstrated by the fact that the average operating efficiency of the 19 Autodin switching centers is 99.85%. Messages are introduced into Autodin from the tributaries as we have previously discussed. The message comes into the technical control center of the ASC, to the cryptographic area, and to the bit buffer units. The messages, in serial bit form, are collected into characters and transmitted into the Accumulation and Distribution Unit, ADU. The ADU collects these characters into line blocks consisting of 80 characters and 4 control characters. The Central Processing Unit, the CPU, queries the ADU and asks, is there an output line block available? If the answer is yes, it will schedule a message segment to be brought in. As it brings the message in, the CPU checks to ensure the message format and security are correct. The information is then stored in a mass memory unit and simultaneously recorded on 2 identical magnetic tapes called history tapes. If the mass memory unit becomes saturated, the messages are temporarily stored on magnetic tapes called intercept or overflow intermediate tapes. The program library tape provides the software program which controls the operation of the CPU. Improperly formatted messages are rejected and a service message is automatically generated back to the originating tributary. If a message comes in with invalid addressees, designators, or routing indicators, the message is processed to the valid routing indicators and a service message is sent back to the originator for invalid routings. The normal rejection rate for the system is only 2% of the total traffic and is usually due to human mistakes in preparation. When high precedence messages come in, printouts occur on the System Console Monitor printer, indicating the time of receipt and time of transmission of the message. The CPU establishes queues for the messages by precedence and by time of receipt of the message. During output processing, the CPU determines the destination of the message. The message is sent back to the ADU, where it is reassembled for transmission, sent back through the bit buffer unit, re-encrypted via the cryptographic equipment, through tech control, and out to its terminal destination in the proper format. During the process, the CPU automatically prints information to the supervisor's console on problems it has encountered and actions which need to be taken by the operators. System status and traffic conditions are printed on the high-speed printer. Autodin is managed by the Defense Communications Agency, which publishes all plans and circulars required for the military departments to operate Autodin. The software programs which are used in the operation of the system, as well as the equipment configurations of the Autodin switching centers, including all phases of installation of new equipment, are controlled by DCA. This concludes our brief look at Autodin. In closing, it is important to note that Autodin has had a tremendous impact in speeding the transmission of messages, ensuring transmission security, and significantly increasing the reliability of their delivery to the addressee.